Okay, hello and welcome to another section in further mathematics. In this section, we'll be looking at the topic, the least square method in forming a regression line. Now, but before we proceed, I'd like us to go back and take a brief review of our previous lesson. Okay, thank you. Now, when we talk about method of least square in fixing our line of regression, you know, there are some things we really need to take into consideration. At first, they said if x is independent variable and y is the dependent variable, that is y on x, then the equation of the regression line is written as this. Now, this will be using this as our regression line, where a is a slope and b is a y-intercept. Given two sets of variable x and y, it can be deduced that, now with this, if we have this variable, it can be deduced that the value of our a, we'll be using this to solve, can be gotten from, that's this a, can be gotten from n summation of x, y minus summation of x, summation of y, all over summation of x square minus summation of x all square. That's for a. So whenever you want to solve regression line, you make sure you look for this value in getting it. Then after getting this, then the value of RB will now be equals y prime a minus a y x prime. Now this our y value is equal to our summation of y over n, and our x value is equal to summation of x all over n. When we talk about summation of n of y and summation of n means the total number of elements involved in the calculation. If we are talking about 7, our n will be 7. Then our total number of y, we are talking about the independent variable. So these are the parameters that we really need to calculate when we are dealing with regression and least square method. I would like us to proceed into solving one question that will help us. Now, let me say we have a table of this nature. This is a blank table. Let's just fill in numbers and use them in solving our questions. We'll have to call here x. Let's call here y. And from our parameters, we need x, we need the value of xy, and we also need the value of x square. So we call here our xy, and we'll call here our x square. Now let's fill in numbers, any number of your choice. Can we just see 3? Okay, 5. We can still use 6. We can use 9. Okay, let's use 11, 14, 15, 18. We are using 18 here, or 19. Okay, let's use the 18. Then okay, let's not fill value here. Let's use it as our total, where we'll add everything that we'll be doing now. Here will serve as the unit of summation. Sum up everything here. So let's add 3 plus 5 plus 6 plus 9, 11, 14 plus 15 plus 18. That is 81. So the value of our sum of x is equals 81. Then let's fix random values for y. Can we just use okay, let's say 2, 3, 5, 7. We can go for 10, 12, 13, 8. No, let's not use 8. Let's go for 17 to have. So we now add 4, 1, 2, 6. Well, that is 7, 10, 2, 6, 9. That's 69. Now xy, let's start. 3 times 2 is 6. 5 times 3 is 15. 6 times 5 is 30. 9 times 7 is 63. 11 times 10 is 110. 14 times 12, 4, 2, that's 8, 6, 1, 168. 15 times 13, 5, 3 is we have 5 1 2, that's 9 195, and 17 times 8 have 7 into 8, that's 6, have 1 0 and 3. Okay, 306. So the total of this point, just getting the total, let's look for x square. Now this is the value of x. The square of this is 9, 5 squared 25, 6 squared is 36, 9 square is 81, 11 square is 121, 14 square is 196, and 15 square is 225, 18 square is 324. Now if we add this, we are having 893, and the summation of this is 1017. Now with this, you can see that we are almost done with it. Let's start looking for our terms that is required. Now the first thing I want us to look for is a. I told us that the value of the formula for our a is n summation xy minus summation x summation y all over the summation of x squared minus x all squared. So we'll count the number 1 2 3 4 5 6 7 8. So the value of our n is 8. Place it here. 8 times 893 minus summation of x is 81 times summation of y is 69 all over summation of x square. Okay, there's n here. Summation of x square is 1017. Remember, there's n here, 8. So and minus summation of x all square, that's 81 square. So with this, we now have that our a. So the value of our a becomes 7144 minus 5589 over 8136 minus 6561, which is equal to 1555 over 1575. So let's proceed. So the value of our a is now 0.9873. Now we've gotten a, which happens to be our first variable. Now let's get the value of our x. This we say is the summation of x over n, which is equals, our summation of x here is 81. So we now have 81 all over 8, because we have 8 terms, 81 over 8, and if you divide 81 by 8, you're having 10.125. We have to get the value of our y bar to be equals summation of y all over n, which is equals summation of y is 69 over 8, and 69 over 8 is giving us 8.625. That's to say the value of our b. I want us to get all our terms. B is equal to y bar minus a x bar, so which is equal to 8.626 minus the value of our a is what, 0.9873 times, and the value of our x bar is 10.125. So our b becomes equals 8.626 minus this times this will give us 9.996. So the value of our b is equal to minus 1.37. Okay, let's finish. Let's get our our formation first before we now know how to finish our line of regression. So we now have it as y is equal to ax plus b. This is our normal equation for regression line. So what we need to do at this point is to bring down our terms that we've calculated. We got our b to be minus, let's get the line, our b was equals minus 1.37. The value of our a was equaled 0.9873. So the equation line is now equal to 0.9873 x minus 1.37. This is our line of regression. This becomes our line of regression. You can see that it's very straight. So at this point with this, remember our x is the independent variable. You can now solve for value of y at any value. Let's say find, you can use this now to start attacking this. Find y when x is equal to 8. It's just a question. Let's try it and see. So from this is our equation. Y is equal to 0.9873 x minus 1.37. Now when x is equal to 8 is y equal to 0.9873. You now put 8 in place of x minus 1.37. So our y is now equal to, if you do this, your value will now be 6.5284. So you can approximate it. Our y can be approximated as 6.5. Have you seen it? So with this, you can keep getting the values of x and the values of y in the same manner. But this is our regression line, our line of regression that is needed, that shows the relationship between y and x. So I definitely think that with this, we've come to a very good terms with least square method in generating regression line. So in order to refresh your memory on what we've just discussed, I'll advise you to take the test that will apply shortly in front of your screen. Always do well to use the lesson notes on this platform for better information on the topic we've discussed. Thank you and see you in our next lesson.